We're looking at the first semester practice final. This is in your yellow book if you have one, but it covers 56 problems and it covers chapters 1 through 6. First problem we have, we're asking number 1 to name 3 collinear points. Collinear tells us that we're looking at 3 points on the same line. So we need to find an answer here where we have 3 points all on the same given line. If we look at SVP, answer A. S and V are on the same line. S and P are on the same line, but there's not one line going through all of them. Whereas if we look at SPT, those are all on line M. Those make them all collinear, so that looks like a good answer to check. But let's look at the other two just to make sure. We have VRP, which maybe if we could draw a line through them would maybe work, but we're not allowed to do that. We can only use the ones we're given. And then KQT. KQT also, and maybe if I extended KT, it would hit Q, but I don't have that. I'm not given that. There's no intersection there, so we're going to go with B, SPT. Number 2, we need to name 2 parallel lines. One thing we're going to have to look for at first is those indicators for parallel lines. We have those arrows there, so that says maybe VS and TK would be parallel. So if we look, we have VS, KT, means the same thing. Those would be our parallel lines. Number 3, you need to see which statement is true. And notice on these, answers A through C are all rays. Answer D is a segment. So that's the part that's going to be different. Normally, if they gave us lines, we look at what it contains. It's just finding the point on the line. We have to be careful here in the types of lines. For example, with SP, that's a segment that starts at S and goes to P. It doesn't go beyond points S and P. It's everything between them. Well, T is not between them, so that's out. If I look at PT, PT is a ray that starts at P and goes through T. It's really everything on the left or the right side of point P that goes through T. Well, S isn't there. As with PS, that's anything on the left side of point P on the line that goes through S. T isn't there, so both those are not possible. Our last one, answer C, starts at T, goes through P, and then keeps going to contain point S. So we'll go with answer C. Number 4, we need to identify what types of lines we have here. We're looking at CD and line AG. Things we know for sure. They don't intersect. There's no point they share. They're not on the same plane. They're really on separate walls of the box. Parallel, we would have to have some marking, or maybe if they're both perpendicular to the same line, something to tell us there. We don't have that. Also for parallel, they'd have to be on the same plane. That doesn't work either, which leaves us with our best answer of skew. And skew means it's 2 lines that do not intersect and are not on the same plane, which is what we have here. Number 5, what is the process of using facts and definitions to form logical arguments? Well, first of all, intuitive testing and hypothesis testing are not terms we've looked at. So those are kind of out. Really, it's between deductive reasoning and inductive reasoning. Deductive, we use facts, we use theorems, we use our rules, and we make the logical arguments. Inductive, we look for patterns and look for specific examples. There's usually some jump in our reason. Well, we see this, so maybe it must be that. Not the case here. If we're using facts and definitions to form a logical argument, it is deductive reasoning. And again, deductive reasoning is what we use when we make proofs or make our formal arguments as we go through geometry. Number 6, which postulate or definition is demonstrated in the statement? I'm given that B is somewhere between K and D. I don't know if it's in the middle. I don't know if it's closer to K or it's closer to D. I just know it's somewhere in the middle, and if I had a segment, KD, it'd be between them, or be somewhere on that segment. So now I have KB and BD are equal to the whole thing, which is KD. I'm adding the parts, KB and BD, to equal the whole thing, KD, so that would be our segment addition postulate. On number 7, we're still using the same start here. We have B is between K and D. But this time they tell us that KB and BD are congruent. So those two segments are exact copies of one another. They don't tell me I'm adding here, so I'm not segment addition. This doesn't look like distance formula, so it's not distance formula. We have to be careful. C looks like a good choice because it does have congruence, but for it to be C, we would have had to have that KB equals BD. The measurements are the same, therefore they're congruent, which we don't have necessarily. What this is going to be is midpoint. Whenever we look at midpoint, we have two congruent parts. It cuts it in half at a point, and so B would be our answer. For number 8, we have that AC is congruent to BE. So if we start off, we're looking at segment AC. That's from A to C, so that's 3x plus x plus 4. And that's from B equal to BE, and that's from B to E, which is x plus 4, 2x minus 1, and 5x minus 7. Really, we're going to set it up, we're going to solve for x, plug back in, and find what we're looking for. You may notice here we have x plus 4 on both sides, and that's because BC was a part of both of them we were looking at. We don't necessarily have to put it there, we could subtract it, but we'll keep it in this case. So we have 4x plus 4 when we combine our terms on the left side. When we combine our terms on the right side, I have an x, a 2x, and a 5x, which is 8x, a negative 1 and a negative 7, which is negative 8, plus 4 gives us negative 4. So I have 4x plus 4 equals 8x. I'm going to add 4 to both sides. I have 4x plus 8 equals 8x. I'm going to subtract 4x from both sides. I get 8 equals 4x, so I get to x equals 2. We have to be careful here. We're not looking for x, we're looking for BD. BD is from B to D, so it includes the part of x plus 4 and 2x minus 1. Well, we can kind of look real quick. If I have 2 for x, then that means BC is 6. That's 2 plus 4. And 2x minus 1, I plug the 2 in, that'd be 4 minus 1, or 3. So we get 6 plus 3 gives us BD is 9. For number 9, we're looking at the midpoint between our 2 points L and M. Our midpoint formula means we add the x values, and we add the y, or add the x values divided by 2, add the y values divided by 2. Really looking for the average, or that middle point for the x's and the y's. Reminder for a midpoint is our answer needs to be in the form of a point. It's not one number, it's a point that we could find on the graph. So if I have my x values, negative 3 and 6, my y values are 4 and negative 2. Negative 3 over 6, negative 3 plus 6 is positive 3, so positive 3 over 2. 4 plus negative 2, or 4 minus 2, is 2. So that becomes 2 over 2. So I get 3 over 2 and 1 as my coordinates for the midpoint. Number 10 is the midpoint formula's good friend, distance formula. This, when we set it up, it's x2 minus x1 squared plus y2 minus y1 squared. What we're really doing here is we're not solving, we're just plugging in the values and seeing which is the correct setup. And what it's really testing you here is, do you know that you need to add them once they're squared, and you subtract on the inside. We subtract on the inside because we're looking for the difference of the x and y values. So if I go in to set them up, first off I take the x2 and y2 as my leading points, and I see, well, those could be 4 and negative 6. They're not the front terms here. I don't have to put 4 and negative 6 in the front. I just like to put those 2's there because it reminds me I have to keep them organized. So let's make these actually x2, y2, and this one x1, y1. So now when I set it up, I have negative 3 minus 4 squared and 5 minus negative 6 squared. If I simplify that, I get negative 3 minus 4 squared and 5 plus 6 squared. Which I check my answers. Which one looks the same? It looks like it's going to be answer D. From there, I'd combine the terms, I'd square them, add them together, take the square root, and it would give me the distance from the 2 points. And that would come out to be a value because we're looking at distance. Number 11, we're looking at the measure of ABC. ABC is the whole thing. This is angle addition. So 134 equals 3x plus 1 plus x minus 1. We then say 134 equals 4x. We need to divide 134 by 4. Oh, we made a mistake here. It should be 3x minus 1. So that's 4x minus 2. So we're going to add that 2 over. We get 136 equals 4x. So x is 34. We have to be careful. That's not what we're looking for here. We're looking for the measure of DBC. So we need to plug in 34 into x minus 1, and it comes out to be 33. Our answer is 33. That is the measure of DBC. But notice 34, which was x, is one of our answers, and it would be the incorrect one. Go back and make sure you read the question. Number 12, we look at our two angles here, 5x minus 14 and 3x plus 2. What we know about those angles is when we combine them, they form a straight line or a straight angle. We know that straight angle is 180 degrees. This is also what we would call a linear pair, which is supplementary. So 5x minus 14 plus 3x plus 2 gives me 8x minus 12 equals 180. Add 12 to both sides. I get 8x equals 192. Divide 192 by 8, and I get 24, which is my value for x. In number 13, we're given that angle 1 and angle 2 are supplementary, and we know the measure of angle 1 is 67. So if we sketch that, we know we have angle 1 and angle 2. Angle 1 happens to be 67 degrees. We need the other angle. Well, if they're supplementary, we know that angle 2 is its supplement. We know they add up to 180. So let's just subtract 67 from 180, and we get 113, or D, for our answer. In 14, we're given that the measure of L is twice the measure of its complement. From reading it so far, we know if it says complement, the two angles add up to 90 degrees. So we have L, and we have its complement, some other value. So whatever they are, they add up to 90 degrees. But the fact that it's twice the measure tells us that if L is 2x, we're going to call the other angle its complement x, because it's going to be twice. Whatever it is, still has to add up to 90. Whatever it is, it's going to be twice that. So that lets me set up that x plus 2x equals 90, or 3x equals 90, which means x equals 30. Not our answer, because we have to plug it in, make sure we find L. So that tells us L would be 60, and its complement would be 30. We check real quick. Yeah, that is twice the complement, so B is our answer. For number 15, it says we need to solve for y, but we can't solve for y. We have to solve for x first.
Can you please call 1332? Cynthia, where's the, can you please call 1332? Thank you.
The two x values, 3x plus 18 and 5x minus 4, are vertical angles, so we're going to set those two equal to each other. I subtract 3x from both sides. I get 2x minus 4 on the right, 18 on the left. Add 4 to both sides, and I get to 22 equals 2x. Divide by 2, we know x is 11. X by itself doesn't help us to our answer yet, though. What I need to do is take that 11 and plug them into either angles that have x. I'm going to pick the one that looks a little easier. 5x minus 4 turns out to be 55 minus 4, or 51 degrees. The angle vertical to that, or 3x plus 18, would also be the same if I plugged in 11. But now that I have that that's 51, I know that the angle on the bottom, where the 3 times 4y plus 3 is its supplement. So this angle is 180 minus 51, or 129. So we have 129 degrees here. We're getting closer, so now we can take that 129, set it equal to 3 times 4y plus 3, and now we're at this point we can finally solve for y. I have two options here. I can do distributive property and multiply 4y plus 3 by 3, or I could divide both sides by 3, which would drop the 3 outside the parentheses, and let me reduce that 129. It makes it a little smaller. I'm going to do that. If I divide 129 by 3, I get 43 equals 4y plus 3. Subtract both sides by 3, I get 40 equals 4y, to which we get that y equals 10. So that is answer A. We follow that up with another fun problem, 16. This one's even better because it has fractions in it. We know that RQT is the whole thing. It's the total of the angles. We know we need to add the parts of RQS and SQT to equal RQT. So we're going to say 2x minus 47 equals 1/2 x plus 4 plus 3/4 x minus 6. Clean a few things up here. I get 2x minus 47 equals 1/2 x plus 3/4 x minus 2. Let's add 2 to both sides. So now 2x minus 45 equals 1/2 x plus 3/4 x. We have a few different approaches we could take here. Some things we could do. We want to combine the 1/2 x and the 3/4 x. To combine fractions, we need like denominators, and we add the numerators. So 1/2 x and 3/4 x we could make into 2/4 x plus 3/4 x, which eventually gets us to have 5/4 x. We also have, now, really have that fourth. What may make it nicer is if we multiply everything by 4. Since 4 is the denominator in the 5/4, if we multiply everything by 4, we then drop the denominator and we get rid of our fractions. So that would give us 8x minus 180 equals 5x. Well, now we subtract 8x from both sides. We get negative 180 equals negative 3x. Divide negative 180 by negative 3. We get x equals 60. Be careful, though, that's not quite the answer we're looking for. We've done a lot of work, but again, we're looking for RQS. So we come back up here. We're looking for 1/2 of 60 plus 4, which we get from right there. That'd be 30 plus 4, which tells us 34 is our answer. On 17, we need to name the property that we have. We have x equals y and y equals z. Then x equals z. We have y in both of those statements. It links the two. It is that middleman that gets us from x to z. When we have that exist, we're going to say it's C, transitive property. For 18, we have the measure of A plus the measure of B equals 80. And we know the measure of B equals 50, so we've replaced the measure of angle B with a 50. Whenever we replace, we substitute. So it's just looking at taking this statement and replacing it, that 50 for B, and forming a new statement. Number 19, we're looking at angles 2 and 8. Well, we can just start eliminating answers. Supplementary, well, that could be a variety of ways to get to that. We'll come back to that one. Alternate interior. 2 and 8 are not on opposite sides, nor are they between the parallel lines, so that's out. 2 and 8 are also not in the same position, so they're not corresponding. 2 and 6 would be corresponding. 4 and 8 would be corresponding, so that's out. Alternate exterior. Now, well, although they're both outside the parallel lines, K and N, they're not on opposite sides of the transversal. 2 and 7, 1 and 8 would be alternate exterior, so that one's out. It leaves us with supplementary, but let's make sure we know for sure. If I take that 2, its corresponding angle is 6, so then I know that 6 and 8 would be supplementary because they're a linear pair. Replace that idea with 2, and 2 and 8 are supplementary. If we go to number 20 now, which angles are congruent? Well, if we start with corresponding angles, I have 1 and 3 are corresponding. Not one of my answers, but if I kept going, 3 and 5 are vertical, so that means 1, 3, and 5 are all the same. 1 and 5 would be alternate exterior angles. If I look there, 1 and 5, that is my answer for C, so I'm going to pick that one. But if we go a little bit further, we know also that 2 and 4 are the same because they're vertical, and there's not really any other connection we can make. It's two groups. There's angles of 1, 3, 5 that are the same, and there's angles 2 and 4 that are the same. They may be supplements of each other in the different groups, but we just have to keep them separate. On number 21, we're filling in the blank. So we start with our given, then we look at what we now have. We have the measure of angle 1 plus the measure of angle 2. That's these two angles are equal to AOC, so the sum together. If we add two parts, we get the whole. For 2 and 3, we do the same idea. BOC, COD, or 2 and 3, we should say. Add those together to get BOD. This is going to be angle addition. Angle addition postulate. Add up the parts, it equals the whole, so our answer is B. For 22, we're given that angle 1 is 110. If we go ahead and just mark the congruence we know 4 is vertical, we know 5 is corresponding, we know 8 is alternate exterior to the 110. So any answer where 4, 5, and 8 are 110 is going to be a correct answer. 4, we don't have that. 8, well, we have it's 100, but it's not 110, so that's definitely out. And 5, well, 5 is 110. We're going to go with answer D. Now, just to make sure we know, 2, 3, 6, and 7 would also be the same as well, and those angles would all be 70 degrees, because those are supplements to the 110. 23, which will prove that line L is parallel to line M? This is where we're looking for the angle pairs we have: corresponding, alternate interior, alternate exterior, and consecutive interior. Since it looks for congruence, we're only going to use the first three: corresponding, alternate interior, alternate exterior. If I have those two are congruent pairs, then they give me that the lines are parallel. So we start with 2 and 7. 2 and 7 are not any of our pairs. They're outside, but on the same side, we don't have a pair there. We don't know anything about them. We do another supplementary. They're definitely not congruent in all cases. 3 and 6 are consecutive interior. Those are actually supplementary. They're not congruent, so that's out. 5 and 2, I could say that 1 and 5 are the same, so that maybe makes them supplementary, but again, we're looking for congruence. That one's out, but 1 and 7 are alternate exterior, so our answer is D. Now we go into 24. In our diagram, which statement do we have as correct? Notice here that NP, LM, those line pairs are all parallel. So let's start through it. Let's see. We have 2 and 11. 2 and 11 are not on the same transversal. They're not on the same lines. If we're going to say that they're congruent, we have to do a couple steps to get there. Notice I'm at this intersection. I may have to get to this one to get to 11. Could take some work, but just off the bat, we're probably not going to use that one. We'll come back to it if we need it. 4 and 11. 4 and 11 are on the same transversal M. So if I have 4, I know it's congruent to 12. If I know 11, I know it's congruent to 3 since they're corresponding. So looking at those, I see those would be supplementary because they match up or corresponding to supplementary angles, 3 and 4 or 11 and 12. So that one looks like it's going to be a correct one. Let's keep going to make sure. 12 and 9. 12 is corresponding to 10. So I know these match up. Well, 10 is not going to be corresponding to 9. So maybe that's more of a supplementary we could have looked at, but they want congruence. So that one's out. 15 and 11 are alternate interior. Alternate interiors are not supplementary. They would have to be congruent. So again, B is our best answer. For 25, we have some parallel lines. We could go and we could find maybe that this angle 36 is alternate interior to this angle, which is 36. And that lets us say that 36 plus 88 plus 2x equals 180. Lets us solve. But even easier, I could take this angle, and whatever this angle is, which is 2x plus 36, I know those are supplementary because they're consecutive interior. So it would be the same case, 88 plus 2x plus 36 equals 180. Still would be the same setup. We're going to solve it. 36 and 88 give us 124 plus 2x equals 180. That gives us, if we subtract 124 from both sides, 2x equals 56. Divide by 2, and x is 28. In 26, we need to find the measure of angle y. We have almost a little too much information. If I draw just my parallel lines, and I have this line here for the 50 degrees, that's my transversal for my two parallel lines, and I'm looking for y. Well, let's see. This angle and this angle are alternate interiors, so they're both 50, which means y is the supplement to 50, or 180 minus 50 equals y, which tells us y is 130. Maybe that's not the only way to get there, but sometimes if we redraw it with just a little bit of the information we need, we can see it a little clearer. Realize there also we could have said the corresponding angle to the 50, which would be up here. Also puts it there, would also be the same setup, so we'd be okay. 27. Which type of triangle has two angles that measure 30 degrees? So if I draw that triangle, I have a 30 degrees, a 30 degrees, and we'll just call it x. Well, we might get in a trap here if we know just those values and we just say, okay, it's just another third angle, whatever it is. But in a triangle, that angle has to be something. It has to be the same value at all times, because 30 plus x equals 180. So that's going to set it at a value that may indicate to us which value or which type of triangle we have. If I solve for x, I get x is 120. So now instead of an unknown angle, we know that angle is suddenly 120. So what's it going to be? Obtuse? Well, obtuse means I have an angle greater than 90. 120 is certainly greater than 90. So I'm going to go with A. Now B is scalene. That means that all sides of the triangle are different lengths. Even though we have angles here, we can kind of make the assumption that since I have 30 and 30 here, it's actually an isosceles triangle because these opposite sides would be the same. Not going to be scalene. Certainly not acute if I have a 120 degree angle. And it's not equilateral because not all of the angles are the same, or 60 degrees, which would make all the sides the same. 28, which is an acute isosceles triangle. We know an isosceles needs to have two sides the same. Since two sides need to be the same, I know that B is automatically out. Only is scalene, all three sides are different length. Now, it's acute. That means all angles have to be less than 90. A is a nice answer, but I have a right angle there. That is a right triangle, so that's out. If I look at C, I have 30 and 30, because those are the same, which means that's 120. That's an obtuse triangle. That's out. D looks like our best choice. We'll make sure. That's 50 degrees also. 50 and 50 is 100. Subtract from 180. It leaves us with 80 degrees at that top angle. Therefore, it is an acute isosceles triangle. At number 29, we're given that the right triangle, we have the side LM, and that has a slope of negative 2/3. We need to find the slope of MP. Now, it's not on a graph. We're not given values for the slope. What this requires us to know is the slopes of two parallel lines. If I have two slopes for parallel lines, call them M1 and M2. Not parallel, we should say perpendicular. Slopes of two perpendicular lines, if these are my two slopes, if I multiply them together, they're equal to -1. That's one way we could look at it. But if we rearrange it a little bit when we're looking at perpendicular lines, and I move, say, slope 2 to the other side and divide both sides by M2, I get -1 over M2. Totally within my rules of algebra, and that's fine. But now when I move it over, it tells me something. If I have the slope, and I want the slope of a line that's perpendicular to it, I'm going to take its reciprocal, or flip the fraction, and change the sign. So I'm going to take that idea, -2/3. If I changed the sign and took the reciprocal, it would be 3 over 2. Now, let's check to make sure. 3 over 2 times negative 2/3. If that works for the perpendicular lines, it needs to equal negative 1. When I multiply fractions, I multiply across. Negative 6 over 6 gives me negative 1. It fits our rule, so that means the slope of our perpendicular line, MP, is 3 over 2, or answer D. Make a note here, if they ask for parallel of LM, it wouldn't in this case because it is a right triangle, but the parallel line would have the same slope. So a parallel line would have a slope of negative 2/3. Not asking for that. Not asking for that in this one, though. Okay, number 30, we have values for each angle, and it's angles inside a triangle. We need to find the measure of angle A. We need to use the fact here that 3x plus 4x plus 5x equals 180. 3x and 4x is 7x, plus 5x is 12x. 12x equals 180, divide by 12, and it looks like I get 15 for x. Not what I'm looking for, though. Again, I'm looking for the measure of angle A, so I go back, plug it in. 3 times 15 is 45. So that's the measure of angle A. If I do a real quick check, that means this angle would be 60 when it's 4x. 5x would be 75. 75, 45, and 160 add up to 180. Make sure they still add up to 180. Check your arithmetic. Make sure you don't make arithmetic errors. And I get the angle A is 45 degrees. 31, I'm looking for angle X. And this is the exterior angle theorem. The exterior angle, X, is equal to the sum of the two non-adjacent angles, these two angles. I know one of them is 70. I need the other one. Now, the fact that I have these markings here tells me it's an isosceles triangle. In an isosceles triangle, the opposite angles are the same to the congruent sides. 70, that makes this one 70. So now when I need the exterior angle, it's 70 plus 70, or 140. 32 is the same idea. I need BAD, my outside angle. I could go the long way here, do 42 and 90, subtract, or add them together, subtract from 180 to find the interior angle right here. Then subtract that from 180 to find the outside. But again, the exterior angle is equal to the two non-adjacent interior angles, or 42 and 90, which is 132. That is answer C. In 33, I need to find angle Y. I'm going to break this down also to an exterior angle problem. I have the vertical angle to the 40. That now gives me a problem where I have Y, 40, and 60 are my values known. Y is the exterior angle when I get rid of the extra information I don't need, which tells us that Y is 100 degrees, or answer D. Next we go to number 34. We need to determine if our two triangles are congruent, and if so, by which congruency. I have a right angle at Z. That works for both. So they're right triangles. I have WX, XY are congruent. I also have XZ is congruent by reflexive property. Now, what I have so far, I have two sides and I have a right angle. Now that right angle could either mean I have right triangles and it's going to be hypotenuse leg, or I use that right angles are congruent and they're going to be angles that maybe side angle side would work. Those are my two options. Now, I know B isn't going to work because I don't know anything about WZ and ZY. So side, side, side is out. So if hypotenuse leg or side angle side works, then I'm going to pick one of those. If neither of them work, it's going to be D, not necessarily congruent. Well, in this case, I have two sides and an angle. But notice how the angle is not between the sides. If the angles were at the point X, up here, then it would be side angle side. Not the case. So hypotenuse leg, we need a right triangle. We have those. Hypotenuse, we have those. And one leg, which is XZ in each triangle, gives us hypotenuse leg. For 35, we have our two triangles. We need to know how they're congruent. Now we match up all three sets of angles, three corresponding angles, and they do match, which say, okay, maybe it's angle, 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 but there's a problem with that. We don't have any congruences that are angle, angle, angle. We have to have at least one side. Think back to all your different congruences. Side, angle, side, 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 hypotenuse leg, which we just looked at, angle, side angle, and angle, angle, side. In all of those, we have at least one side. We don't have that here. We need the side to make sure they're the same size. So angle, angle does not work. Angle, 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 angle. So our answer is actually D, not necessarily congruent. Now, if this question said, how are they similar, which is not the same as congruent, it's just the same shape, not necessarily the same size, then we would say C maybe would work, but we would just call it angle, angle. But in this case, since it's congruent, D is our correct answer. In 36, we're given that AD and BC intersect at X, then AX and XB are the same, CX and XD are the same. Which congruence is true? Well, I also have a vertical angle. I can mark that here. But what it comes down to here is we have to name our congruence statement. Now, we could look at it two ways. We could look at matching each answer, or notice that each answer has ACX as that starting triangle. So it's not match the two, it's say which one is congruent to ACX. Well, if I go through each one, I have ACX and match up the corresponding parts. I need to know what's corresponding to A. Well, I look in this triangle. A is at the top where the one congruence mark, one single tack mark is. That means B is corresponding to it. C is down, it's at the end of the double tack mark. D is corresponding to that. And then X is corresponding to itself, so my corresponding triangle would be BDX to ACX, so C would be my answer. On 37, which of the following could not be the lengths of the sides of the triangle? In this case, I'm going to use the longest side must be less than the sum of the other two sides. This tells me if it makes a triangle. I'm looking for how it doesn't make a triangle. So if we think of this as our test to figure out if it's a triangle, we want it to fail. The answer that fails the test is our correct answer. Well, 19 is our longest side. That is less than 8 and 15. That's true, because 8 plus 15 is 23. So that's a true statement. Didn't fail. 89 is less than 89 plus 5. Well, I would hope so. A number is less than itself plus something. So that one passes. 9 is less than 4 plus 5. Well, at first, maybe that's okay, but if we look a little further, 9 less than 9, that's a problem. That fails our test. That's the one that could not be the length of the triangle. C is our answer. We look real quick at the last one, 4 less than 2 plus 3. Well, 4 is less than 5. That one passes. So that one's also true. C is our incorrect answer. Or C would be our correct answer because it does not make the triangle. 38, we have cities that are distances apart. We know that A and B are 11 miles apart. B and C are 16 miles apart. We need to know what our possible value for A to C is. Now, we could use the rule we used up on 37, but that's going to require a couple different inequalities. We have a different rule we can use here, and this is to find a possible third side. We look at the difference of the two sides, and we look at the sum of the two sides, and we know that our third side is some range between them. So, I have 11 and 16. The difference between those two is 5. The sum is 27. So, the possible third side between them, not including them, but between them, any number greater than 5, less than 27. Well, if we look at our answers, 6 would be the answer. It's not 5 because if it was 5, it wouldn't fit our inequality. We looked it up here. But if we check 6, that means our longest side, 16, is less than the sum of the other two. 16 is less than 17, so that is our correct answer. 39, it's going to be the same type of problem. I have y, z are 12 miles apart. X, y are 8. Possible distance, I have the difference is 4. The sum is 20. I need some value between 4 and 20, not including 4 and 20, and it's going to be 19. 19 is less than 20. All the other values be greater than or be equal to 20, and that's not going to work for us. If we go on to number 40, lengths of two sides of the triangle are 15 and 20. Length of the third side of the triangle would be between which two numbers? Still the same process. We look for the difference of the two and the sum of the two. So it's the two numbers between 5 and 35. Number 40 is a problem where we look at the angle bisector. These two angles are congruent. They bisects. That means that 6x plus 2 is equal to 4x plus 8, and that is because this point here is equidistant to the sides, and that is that length back to the sides we're looking at. So I need to solve here. I subtract 4x from both sides. I get 2x plus 2 equals 8. Subtract 2 to both sides. 2x equals 6. So I get that x equals 3. 32 is a midsegment. We have to be careful with the midsegment because if we're careless, we'll just go and set those two values equal. But they are not equal. They are parallel because that fits the definition of the midsegment. But we have to double AB and to set it equal to 5x plus 4, or mn. That's because the midsegment is half the length of the side it's parallel to. So 2 times x plus 8 equals 5x plus 4. We could have also taken half of 5x plus 4, but the fact that that's odd, we're not going to do that because we don't want to give us fractions when we don't need them. I double and I get 2x plus 16 equals 5x plus 4. Subtract 2x from both sides. I get 16 equals 3x plus 4. Subtract 4, I get 12 equals 3x, so x is 4. We look back real quick. Are they asking for x? They are, in fact, so it is B. 43, I need to find angle C. Notice I really have two triangles that are overlapping. I have the 45 and the 80. That goes to this third angle in the triangle. I'm going to find that one, as well as the 50 and the 100 have this third angle. When they overlap, they form a triangle within that, and that C is that other angle in there. So I need to find those angles first. I have 50 and 100, so their third angle would be 30. I have 45 and 80 is 125. Subtract that from 180, I get 55. So 55, 30, and C are within the triangle. So I'm going to solve for C within that triangle. 30 plus 55 plus C equals 180. 85 plus C equals 180. So C is 95. Okay, last one on this page, we have 44. Using the information in the drawing, which angle has the least measure? The smallest angle is going to be opposite the shortest side. Our shortest side is YZ, so that is opposite angle X. Keep in mind, when we're looking at opposite sides and opposite angles, if I have a side and I want its opposite angle is the letter I didn't use. So YZ goes to X. Angle X is our smallest angle, but they happen to give us all of these answers with 3 letters. When we go from 1 letter naming the angle to 3, the vertex, or X in this case, will be the middle letter. So it's the answer with X as the middle letter, so that is C, angle ZXY. The other ones would have the angles at vertex Y and Z, which are not the least measure. Number 45, we're given the diagram with the indicated angle measures. We need to figure out which segment is the longest. We're going to use the same idea where the longest segment is opposite the biggest angle. Normally we've seen where we just had 2 triangles next to each other, but we have a third one here, and we can still work through this one. If I start in each triangle, I have 64 is my biggest angle in triangle ABE. That's opposite BE. So in this first triangle, BE is my biggest side. In the next triangle, I have 66 degrees is the biggest angle. That is opposite CE, which is my biggest side in that triangle. Now, before we go any further, let's make sure we have a candidate from that triangle, because if it's a candidate from this middle triangle, maybe that helps eliminate something as we work our way through. So I know in this middle triangle I have CE and BC. How about BE? BE. Now, this is the longest side in each triangle. The longest side total out of those two triangles is CE. So although BE may work in its triangle, it is not the longest of those two. So that eliminates one. So now we get to our last one, CDE, and I have that the longest side is opposite 61, which is CD. So now it's between CE and CD. Now in just this triangle where they both are, one of them is opposite 60, one of them is opposite 61. The one opposite the 61 is greater, so we're going to say CD. Number 46, it's a indirect proof. What would we assume temporarily as our first step? We always take the given that we want, and you take that given and we use that information. It's the proof we want the opposite of, because if we prove that the opposite doesn't work, then that means the original statement would work, so we assume that the measure of angle B is not equal to 40. In 47, we have the two triangles are similar. We need the measure of angle F. Now, I know that A is corresponding to D, because they're both the first letter. So that 37 goes right here. F is the third angle in that triangle, so 37 plus 90 plus the measure of angle F equals 180. I get 127 plus the measure of angle F equals 180. That leaves me with the measure of angle F being 53 degrees. This would also be the measure of angle C if we were asked for it. In 48, we need to find what would we fill in the blank for our proportion. I have AB over AD, and then what over AE. I'm going to draw these two triangles separately here. I have ADE, and big triangle ABC. So AB is this side on the big triangle over AD. AE is the right side on the small triangle. So that would be corresponding to AC, which is the big triangle, the right triangle, the right side on the big triangle. There we go. So these two match up. They're corresponding, so AC would be our corresponding part. We'd fill that in the proportion. That would make it true. Right, Lena?
Yeah.
Thanks for green. Okay, now 49. We need to determine the width of the river when we have similar triangles here. The width of the river is going to be AE. So we match up our corresponding parts. 8 over 12 equals 10 over x. That sets up my proportion, matching up the corresponding parts. I don't need necessarily EB and BD. I don't know what they are, but I don't need them. I just need to set up the parts. 8 over 12 reduces to be 2 over 3 equals 10 over x. I then do cross products. I get 30 equals 2x, and x would be 15. So 15 would be the distance across the river, or segment AE. Number 15, I'm going to set up my proportion again, matching up my corresponding parts. 18 and x are corresponding, as are 15 and 20. Before we go any further, let's make sure we know that they are similar. I have J and N are congruent. I also have angle L is congruent. That's because it's a vertical angle. So 18 over x equals 15 over 20, which I can reduce to be 3/4. I do cross product. I get 72 equals 3x. Divide 72 by 3, and I get 24, which is my answer for D. For 51, we again have similar triangles, but now we have to find the length of our longest side in x, y, z. Now if they're similar, we know the sides match up and they're proportional, so the longest side in our smaller triangle, ABC, will match up with the longest side in x, y, z. Well, AB is my longest side in AB is my longest side in triangle ABC, so that means XYZ will be my longest side in, XY will be my longest side in XYZ. So it's now just using that relationship between them, that scale factor, to find what value I'm going to need. I have 192 and 576 as common values. They're corresponding, they match up. If I take 192 and multiply it by 3, I get 576. So as a shortcut, I could even take that idea. The XYZ is 3 times bigger than ABC. I could also say 192 over 576 equals 222 over XY. I can reduce, like I said, that's 1/3, and get this proportion. From here, if I do cross product, I see that XY is in fact 666, which would also, I've gotten that if I multiply by 3. Now, what extra piece of information do we need that IJK is similar to LMN in number 52? Now, it's looking at side angle side similarity. So I need another side. I need it so that 12 over 8 is equal to NM over 12, or 12 over 8 equals to LM over 10. Now, I need to find the value that makes it work and see if that value fits. Well, let's look at the second one first. I can do cross product. I get 120 equals 8 times LM. If I divide both sides by 8, I get LM is 15. LM is 10, LM is 18. Those two are both out. Look at my first one. I get 144 equals 8M NM. If I do my cross product, I have to divide 144 by 8, and that comes out to be 18 equals NM. Look at my answers, and that would be answer A. So it's finding that missing piece when I do set up a proportion. If I had the 18 there, my sides are proportional. 53, I need the length of YZ. Could do it two ways. I could find that length of YR first and then add it to the total, or I could find using the two separate triangles, two small triangles to a big triangle to set up my proportion. It's a little easier if I just use that YR first and say 6 over 14 equals YR over 7, but I have to keep in the back of my mind I still have to add it together to get YZ at the end. So I get 42 equals 14YR. Could have reduced there, but I'm just going to do cross product. I divide and I get YR is 3. So that's 3. Now that that's 3, I need to add it to the 7 to get YZ is 10. Be careful, read that directions. Yes, you may find that 3 is correct, but you have to answer the question being YZ. Okay, now into 54, I'm going to set up my proportion. This time I'm going to say 4 over x equals 5 over 7.5. Could also say 4 over 5 equals x over 7.5. It would also get us to the same thing. If I do cross product here, I get 5x equals 4 times 7.5. 5x equals, let's see, 4 times 7.5 would be a 30. Divide both sides by 5, I get x equals 6. 55, I have similar triangles by angle, angle. I need to match up the corresponding parts and then find my missing value. So let's start with some sides here. I'm going to look at AC first. AC is 12. AC is the second and third letter. So that means it's corresponding to MN. So 12 goes to 15. 16, BA, matches with the second or the first and second letter, LN, which is X. That leaves us 20, BC goes to 25. Pick one of them to reduce. 20 over 25 is 4/5 equals 16 over X. Now I can do cross product. I get 16 times 5 is 80 equals 4X. Divide both sides by 4 and I get X is 20. Be careful matching up those corresponding parts there. Get that proportion, then you can solve and find your answer. Last one, we've made this long journey, 56 problems. Our last one is a proportionality theorem. We're going to set up 6 over 8 equals 2x plus 1 over 3x minus 5. I can reduce 6 over 8 and make it 3/4 equals 2x plus 1 over 3x minus 5. From here I'm going to do cross product. 3 times 3x minus 5 equals 4 times 2x plus 1. If I distribute, I get 9x minus 15 equals 8x plus 4. From here, I can subtract 8x from both sides. I get x minus 15 equals 4. Last step, I'm going to add 15 to both sides, so x is 19. X is 19. Be careful though, we almost went and circled the answer, but we need to find AC. So AC is 3 times 19 minus 5. 3 times 19 is 57. Subtract 5, we get 52. You got to be careful there that we answer the question they're asking, not just X, but they wanted AC. Plug it in, 52 is our answer.